It's going to give us that. Then we have this 10%. So we have y dollars, or 0.10 times y. So all we're doing is just trying to take this kind of, I guess it's second piece of information here. We've earned $190. We're trying to make an equation out of that. So we can figure out how much interest we earned on the first chunk of money, how much interest we earned on the second. If we were to add those together, we would have to end up with 190. 8% of some amount plus 10% of some amount equals 190. So that would be our second equation. 0.08 times x plus 0.10 times y is equal to 190. So that perhaps is maybe the trickier part of this question, is trying to figure out how to use that second bit of information, that $190. And there's many ways to do these questions, yeah. There's no one correct way. This is just kind of maybe one way to do it. Okay, so we have a linear system. We have our first equation, which is x plus y is 2,000. And then we have our second equation, which is 0.08x plus 0.10y is 190. Continuing on, we're going to figure out now how much we had invested at each rate. So how much at the 10%, how much at the 8%. So since we're in the solve the system by substitution, we're going to isolate x or y in one of our equations. And looking at equation number 1, it looks like we already have an x and a y with no coefficients in front. So let's start with, I don't want to write a 1 because that's going to confuse us. Isolate equation 1 for x. So I had equation 1 was x plus y is 2,000. I'm going to subtract y from both sides. And I'm going to end up with x is equal to 2,000 minus y. All right, so I've figured out what my x is equal to. Now from there, I am going to just continue the process that we've been doing. So we're going to substitute, I'll just write sub, x is 2,000 minus y into the second equation. And jog your memory here, the second equation was 0.08x plus 0.10y is equal to 190. So I'm going to get 0.08x, but I'm not going to put the x here because I'm going to substitute 2,000 minus y in for the x. Just rewrite everything else. 0.10y is 190. So I've taken the fact that x is equal to 2,000 minus y, and I've substituted it into the equation, my second equation. The next step here is, if you'll notice, I have a y and a y. The only variable I have is y. So we want to solve for y. Okay. We're going to take this 0.8, we're going to distribute it through the brackets, feeding our chickens. 0.8 times 2,000 is the first thing we're doing here. Just 8 times 2 is 16, so I'm making sure I get all my decimals in the right place. I should end up with 160. And then I'm going to end up with 0 or negative 0.08 times y. And then I'm just going to bring everything else down. Plus 0.10 times y is 190. So all I've done is distributed the 0.08 through the brackets. Now I'm going to combine like terms. I have negative 0.8y and I have 0.1y. So I'll bring down the 160. 0.08 plus 0.1 is 0.02 times y, and that's equal to 190. Alex, I just saw your question. I will get to it in a second. All right, I'm trying to get y by itself, so I'm going to subtract 160 from both sides. So I get this 0.02y. 190 minus 160 is going to give me, it's going to give me 30. And then I'm going to divide both sides by 0.02. Which gives me y is equal to 30 divided by 0.2, or sorry, 0.02, which is going to be 1500, I believe. Double check that on my calculator. 30 divided by 0.02, yes, 1500. All right. So I know what y equals, and if you think back to the question, it said we had $2,000. Some of it was invested at 10%, some was invested at 8%. Now I just figured out that we had $1,500 invested at 10%. So if you think about it, if you had $2,000 in total, you invested $1,500 of it at 10%, that's $500 left at 8%. But we should figure out that algebraically. So what we're going to do is we're going to substitute y is 1500 into equation number 1, because that's an easier equation to deal with. So equation number 1 was x plus y was 2000. I'm saying y is 1500, so I'm going to get x plus 1500 is equal to 2000. I'm going to subtract 1500 from both sides. And I'm going to get x is equal to 500. All right, so we have an x, we have a y, and we should kind of write an answer. So it looks like we have $500 and that 500 is at 8% interest rate, and we have 1500 at the 10% interest rate. So that is that. Whew. All right. I know this can be overwhelming, but as long as you can keep sight of where you're trying to get to, you should be okay. And there's lots of ways to do these. You can substitute into either equation to figure out the other variable. The idea is, if you think back to the first lesson we did, you have a graph, you've got two lines, they're crossing somewhere, or they're parallel, or they're on top of one another. Those are the three situations you're going to encounter. You've now been given 3 different ways to deal with them. You can do it graphing, you can do it by elimination, adding, subtracting 2 equations together, or you can do it by substitution. Now, the beauty of this is, on a test, you're likely going to be given 2 lines, and it's going to say, solve the equation. So you're going to find a coordinate to sort of solve the equation. Now, there is three methods now you can use. You can figure out whichever one you want. So generally speaking, one's going to be easier than the others, and you can just kind of go with that. I want to look at perhaps a few more, or there's one word problem that I skipped from last day, from lesson 2, and I want to maybe jump back and look at that. We have about 10 minutes before we're done. So let's jump back to lesson 2, unless anybody has a question about what we've just accomplished here. Thinking no. Okay, so lesson 2, I kind of left you guys hanging on example 2, where we had an equation, and then we had another equation. So we had 2 equations, and it just asked you to say, okay, 2,700 pop cans, 300 bottles, so substitute 27 in here, substitute 300 in here, even says it right there, and figure out if it equals 195. If it does, then your system was right. That was where I left you. I want to just jump down to the third example, because this is a hard one to set up. I have a feeling you might be better at it now after seeing a few other examples, but I want to try to get through this. So the question, riverboat, 2 hours to travel 24 kilometers downriver with the current and 3 hours to make the return trip against the current. Determine 2 equations that could be used to solve for the speed of the boat in still water and the speed of the current. So the idea is, how fast is the current going? If the boat's traveling upriver, it's fighting the current. If it's traveling downriver, the current's pushing it, so it's going to go faster. But we don't know how fast the boat's moving. So can we figure out how fast the boat's moving? Can we figure out how fast the current's pushing it? So we need to figure out what are the unknowns. So the speed of the boat and the speed of the current. That's what the question explicitly asks us to find. So if we need to come up with letters to represent these things, I'm going to go B for speed of boat. And I'm going to write in still water. And then we have C as speed of current. Okay, so we've identified the 2 things we're trying to find: speed of the boat in still water, the speed of the current. We need to take the information we're given in the question and try to figure out a system of equations we can use to solve this. So we have 2 sort of scenarios. The boat's traveling with the current, and we know how long that takes, and the boat's traveling against the current, and we know how long that takes. So we're going to use that information. If we take the speed of the boat plus the current, that's going to be speed of boat. With the current. And then we have B minus C is speed of boat against current. So sometimes putting this in a table is going to help us out. Now, one thing that doesn't get mentioned in the question, but you just basically need to know it. It's one of these few things that you just basically, pure memorization. The distance you're going to travel is how fast you're traveling times how long you're traveling at that speed. It's just one of these sort of kind of, I don't want to call it common sense, but one of these things that perhaps makes sense. If you're traveling 100 kilometers an hour, you're traveling at that speed for 1 hour. How far did you go? Well, 100 kilometers. If you're traveling 100 kilometers an hour for 2 hours, you have 100 kilometers in the first hour, 100 kilometers in the second hour. Just taking this kind of idea that you are aware of and putting it into almost like a formula. All right, so we have 2 directions. We have a direction with the current, and we have a direction against the current. what distance are we traveling each way? So we're going 24 kilometers down a river. So it doesn't matter if we're going with the current or against the current, we're traveling 24 kilometers. The speed is going to be either, in this case, we have the boat plus the current, because we're traveling with the current, and then we have the boat minus the current, because we're traveling against the current. When we travel with the current, it takes 2 hours, and when we travel against the current, it takes 3 hours. So we're just taking information from the question. This is perhaps the tricky bit. We're going to take the time we traveled, multiplied it by the speed, so we're going to use the speed times time to give us a distance. Why are we interested in the distance? Well, we know the distance is 24. So if we take 2 times the boat plus the current, that's going to give us 24. If we take 3 hours with the boat minus the current, that's going to give us 24. And what we have here is 2 equations and 2 variables, and it's all set up. There's example number 4 here, and it's the same as the one we just did, except it has different amounts and different interest rates. So perhaps you want to maybe try setting it up, just like we did in the last question on the lesson 3. Maybe I'll give you a second just to see if you can kind of figure out your 2 variables. You can use x and y if you want, again. And then see if you can fill out the information in the table down at the bottom here. I know we only have a couple minutes left, but I'd like you to try to set up this system, and then I'll throw down the answer, and we'll call it a day. Remember, we have a review day tomorrow, and then you guys are kind of done this unit, so you can write the test whenever you get this learning guide submitted. So I'll give you a couple minutes to see if you can just figure out the system. We're not even solving the system, just kind of setting it up, and we can go from there. All right, guys, I kind of jumped ahead a little bit and wrote down all the stuff. So you had 2 minutes to kind of think about it. It was the same as the question you just did in the previous lesson. So We put everything in the little table here, and we've ended up with two equations and two unknowns, and we'll just write down those equations and see how we can do it. So the information in the table is x and y is 3,000, sorry. So if we have x plus y is equal to 3,000, that is our first equation. And then we had some amount was invested at this 0.5 or 0.05, I should say, at 5%. And then we're adding to it another amount invested at 7%, and that has to equal 182. So that is setting up our two equations. How did we do there? We think we did okay? Somewhat, possibly. So when's the learning guide due? Hopefully you can have it in by the end of the class tomorrow, because we're gonna take next class to just kind of review Unit 7, and then you guys can maybe write the test on Friday if you're ready to do it. If not, I'll definitely be checking on Monday for sure. If you have some unit guides in there, I can do that. And that's kind of it. What is the slope and y-intercept of t is 5 and y is -5? I'm not sure where that's coming from, Alex. It's kind of something I can't answer unless I know more information, I guess. Maybe if you want to throw the question in next day at the beginning of class, we can do it, because all of next class will just be going through some of these problems you guys have from the learning guides. So there you go. I'm going to leave you guys there. Unfortunately, we've kind of run out of time, and we'll pick it up. The t was a mistype, which makes it even more confusing. Y is -5. I gotcha. All right, so if we had a graph just quickly, a graph, here we go. It doesn't matter what x is. Y is always -5. So I find -5, it's down here. There's my y is -5. X could be, 2, y is -5. X could be -5, y is -5. So we're going to end up with a horizontal line. The y-intercept is here at -5. The slope, remember horizontal lines have a slope of 0. So Mr. Ross, can you bring that up again, full screen? Thank you. So there you guys go. Give you a second, make sure you got all that stuff right. And I will leave you there. We'll pick up next day. Hopefully you can get this stuff in tomorrow, and then test on Friday, and then break. Have a good afternoon, guys. Mrs. Ward will be on in a couple minutes with you guys, and maybe we'll see you at the movie tomorrow. Bye-bye.